For our next talk, we have Rahul Pradeep. Rahul is an engineer in the ad tech and discovery team. He spent almost 7 years in Flipkart and built systems like Discovery Jockey, which is our page federation service, and Morpheus, which is our content generation platform. Joining him in this session today is Ruchika. Ruchika is a software developer in the same team. They are both currently working on the generation of a highly scalable content service for real time use cases. And that's what they're going to walk us through. They'll give you a sneak peek into what goes behind the scene for some of the flashy widgets that you see across Flipkart homepage and various category landing pages. Over to you, Rahul.
Thanks, Harika. Hi, everyone. I'm Rahul, and my co-speaker will be Ruchika, and we'll be talking about Morpheus, which is our auto content platform. Essentially, what the system does is the system creates product discovery experiences at scale. So before diving into the details of what Morpheus actually does and some of the internals of Morpheus, let's look at what a typical product discovery experience looks like in Flipkart. Right? So when you land onto our platform and you go to any category page or the home page, what you see is a bunch of cards, creative cards, right? And the creative cards typically will call out some price points, some attributes about the products, right? And also some images, and those images would be product images. There might be a background image like you see on the in the slide, right? And when you click on those cards, what you see is a landing page, and we call it a browse page or a landing page. Essentially, these landing page is a selection of products, right? And you can think of these creatives that you see on your left as as a representation of these product selections, right? So this is how a typical product discovery experience looks like. uh, so before Morpheus, the way we used to create these experiences were totally manual. So what we used to do is we have these category teams. So every shopping category like mobiles or lifestyle, they have their own category teams taking charge of that respective business. They used to create these content manually using an in-house console, and they use their conventional wisdom and experience to do that. While kind of this worked well till the scale was manageable, we quickly realized this will not scale for the millions of users that we have, right? So some of the challenges that we faced were, we our catalog has around more than hundreds of millions of products, right? And we have hundreds of millions of users as well. So to create these tailored product selection for each of those user cohorts was becoming a challenge uh, when we do it manually, right? And with changing business goals, to keep these creatives and these landing page experiences updated was again a challenge to do that manually, because a lot of operational bandwidth was spent on this, right? From the creators front, while we were able to create very rich looking creatives, we were not able to do that in a personalized manner, right? We were still having a very basic experience for our personalized content, like the one you see on your right? So we needed to clearly bridge this gap. Right? And if you see some of the creatives that we saw in the example, we call out some price points, and we talk about, we show an image of the product, etc., right? So essentially, we need to keep these promises when we land onto the landing page as well. So whenever there is a product availability change or pricing point changes, we need to make sure the creatives are updated. And this was next to impossible to do it manually, because you cannot do it in real time and the dynamic nature of those changes, right? And when we kind of went pan India, and when we opened the Flipkart platform for more and more, with more and more language support, we have around 12 languages today. Uh, this kind of blew up, and essentially we would have required 12x of our operational bandwidth to kind of create this content, but it was becoming a challenge. To bridge these gaps, and to address these challenges, we built this platform called Morpheus, which essentially takes our product catalog, keeps the users in mind, as well as takes business goals into account. And using techniques of image processing, ML, AI, and other system architectures, we create these discovery experiences at scale, right? And essentially, what we have done is we have kind of broken down this problem into two parts. One is how to create product selections, which is your landing page, and how to then create a representative creative for that product selection. And we were able to scale to billions of content. We were able to create very rich personalized creatives using this platform, and it was very easy to onboard new business use cases as well, like grocery or Flipkart Quick. And when the newer languages came in, it was very easy to create those content as well through machines essentially. There was no manual input required in this. And we also found out that this is very useful for some of the other businesses like advertising, where we assist our advertisers to create these rich creatives. So previously they used to employ their own design team and creative team to do that. This system helped them create these creatives with a click of a button. So so the first problem to in Morpheus was to create how to create these landing pages, right? How to create these product selections. So Ruchika will take us through how did we solve that problem. Over to you, Ruchika.
Thanks, Rahul. So now the first step to figure out how to automate the creation of product selections was to talk to our category teams and tap into their minds. We tried to enumerate all the stories around which they create contents. For instance, one I'm sorry. Yeah, I want to merchandise shoes from all premium brands which sold more than X units in the last 30 days. Another one could be I want to show products in the user's wish list on the home page in a visually appealing way. Similarly, there are many other stories based on price, discounts, trends, as you can see on the slide. So these stories are basically business criteria specifications which need to be captured in a more structured form. Let's call this structured form as strategy. So this strategy would help us in identifying the product selection rules. This strategy is executed on some data. It passes through a pipeline and multiple product selection groups are generated. So a single strategy leads to multiple product selections, where each product selection is a set of products bound by a set of common rules which adheres to the strategy. So let's go a little deeper. I'll walk you through the pipeline. So there are some raw signals which are used as input and which helps in creation of the product selections. For example, catalog data can be used as a signal. User interest in the form of user activities can be captured. Like if a user is interested in a particular brand, we would want to show products of that brand to the user. If there is a price drop or huge discount on some products, we would want to create product selections showcasing this information to the users. And similarly, many other signals could be used. In order to be able to process this data, we need it in a more structured form. So raw data is aggregated into marketable aspects like category, trends, brands, prices, discounts, and many other product attributes, and populated in a data store. We call this data store as metadata store. Now the strategy, which is actually representing the business criteria which I talked about in the previous slide, is executed on this data store by firing queries on them, as a result of which we get multiple product selections and which comply with the strategy. So let's see an example of the strategy execution. Say the strategy is an input, and here the input strategy criteria is for mobiles category, select brand which are top 10 GMV contributors in the last 10 days. So on the basis of this criteria, we query the metadata store and then we'll get a group of product selections like product selection of Apple mobiles, product selection of Poco mobiles, and so on. So we have covered how the product selections are generated. Rahul will walk you through the flow for the other aspect of the problem statement, that is how to create a representative creative of these product selections. Over to you, Rahul.
Thanks, Ruchika. So now that we have these product selections, the next job is to create a representative creative for these selections, right? So the way we have kind of went ahead solving this problem is first by looking at the creatives themselves and trying to figure out what elements are there in this creative. So in this creative, if you see, there is a brand logo, there is a product image, which is a Poco C31 image. There are some textual elements in it which calls out price point, brand make, etc. And then there is a background image which adds to the richness of the image, right? So most of these information is we were possible. It was possible to get it from the selection itself. So, for example, if you look at this selection, it's very evident that you have these bunch of products and all the attributes related to those products. So, what we do is we do something called as enrichment, where we take these products and gather as much information as possible for these products. So, we figure out what are the images of these products. We figure out the various attributes like brand, the key features like in this case sensor type, the price points, and the category themselves. So if you see, a lot of this information was used in the creative as well. So we take this information and then directly use it in the creative, but still there are some aspects to the creative which you are not able to get from the selection themselves. So in this case, we are able to get all these aspects from the selection, but we were not able to get background image, right? Which is a key element because it adds to the richness of the creative. So we kind of, and these background images are not specific to the selection themselves, right? So because the same background could be used for any other selection as well. So the way we do it is we manage something called as we manage these background images in something called as asset pool. So this is essentially a repository of these static assets, right? And the kind of assets that we manage here are, we have these bigger background images which in this particular case, it kind of caters to lifestyle category, where you have a model standing in one side of the image and then you have some blank space where you could put your textual elements in it. And then we have these smaller background images which are used for certain other kind of formats, creative formats. We also have these textual templates. So the entire textual component, if you see, there are some dynamic aspects like price in it, and then there are some static aspects like in this case the words from, right? And these variables are then resolved at based on the attributes from the product selection themselves. And then we have these real life background images as well. For example, in this case, it's an image of an office desk where there is a space in between where we try to keep we try to place a image of a electronic item and maybe a phone or a tablet to make the creative very real life looking, right? So let's take a step back and kind of figure out how do we actually create these different rich experiences, right? And we employ a lot of techniques including ML, AI, etc., right? So first is a technique called as Photoshoot Transformer. What we do here is, and this is specifically for lifestyle that we did, and we found a lot of success in that. So we take these stock photoshoot images like the one you see here, which are proprietary to Flipkart, and then we run it through an object detection ML algorithm, right? So we detect clothing items in this image. So here, if you see, there are four clothing items: the shoe, jeans, shirt, and the eyewear. We detect them, and then we try to create spaces around those items, right, to create some space for your textual components. That's how these backgrounds are created. So to even create those space, we needed to figure out what is the gaze of the model, because when we talked to our design team, we figured that that is something that they care about, the gaze of the model themselves, right? So we figure out the gaze of the model. Again, there is another model in play here, and then we kind of crop around each of those detected clothing item and then expand around that in the direction of the gaze, right? So here, as you can see, there is one photo shoot image which kind of gave us four creatives, right? And there are other examples. In this case, this is the model has a neutral gaze, right? She's looking in the front, right? So here you could potentially create more background images extending to the left as well as to the right. And then you could also break it down into the smaller formats, right? For the smaller background images. So here again, you can see that there are six background images created from this one image. So we have particularly found success in this particular in lifestyle category. Right? Other kind of rich images that we create are where we place products in a real life background. And for in this case, there is a TV product, and we place it on top of three backgrounds, each of them having different elements in the background, right? Each of them having a different TV unit in this example. So how do we do that? There are a bunch of models in play. We will not go into the details, but we'll just take an overview of it. So what we do is we take these product images and we figure out if it has a shadow or a watermark in it, because a lot of catalog images are not essentially a clean PNG that you get. It's not having a transparent background. It might have a shadow, it might have a watermark as well. So we don't want to use them because it will look bad in your final creative. So we detect whether it has a shadow or a watermark. If it doesn't, we move on to what is called background subtraction. So we, if there are just white pixels or gray pixels, whatever surrounding the product, we kind of subtract them out and create transparent pixels instead of those pixels, and essentially generating a PNG in the process. So once we have this PNG, we also do things like QCs on top of it to figure out whether we have done a good job in subtracting those pixels. And then we also detect whether this product is having a front view or not, because usually when we talk to our design folks, we figured that they usually prefer products with a front view, so that it looks better when you finally render these on real life backgrounds. So that is detected again using a model, and then we finally move on to the rendering phase, where we put a shadow as well, because in a real life situation, you always, the shadow gives a very good look to the creative, right? So in this case, you put a shadow and then final rendering, and this is how and everything happens through different stages of machine learning models, right? And then there are other use cases where you want to club multiple products and then render it on a real life background. In this example, we have done that for beauty products, right? So where you have taken multiple products, did the same process of background subtraction, QCs, and everything, and then we have placed them together into a real life background. Much of the models are same that we have seen before, but there are additional complexities here. For example, I cannot, the relative sizes of the product should be honored. So in this example, the lipstick image cannot be bigger than, let's say, the Nivea cream bottle, right? And also to make sure that one product doesn't kind of sabotage the other product by if we place it on in front of that product, right? So this is something that we are working on right now, and will be particularly useful for categories like beauty segments and groceries, etc., right? uh, Now that we have seen all these capabilities that Morpheus provides, let's look at what are the system requirements, right, from these capabilities that we have seen. So clearly, because creative itself has a bunch of elements in it, and we need to compose it to form a final creative, we need composability, and we need to do that very efficiently, right? And then we need to make sure that the pricing changes and the product availability changes are updated correctly on my creative as well. So we need a continuous kind of processing here and continuous update of these creatives whenever a change occurs, right? And then to do all of these things efficiently and at scale, we need very high throughput. So keeping these things in mind, let's look at how the architecture kind of looks like, right, at a high level. So the input to creative generation is this product selection, which came out of the strategy execution that Ruchika had explained earlier, right? So once we have this product selection, as I said, we'll try to gather as much information about this product selection by looking at my catalog data and many other systems, right? And we call that phase as product selection enrichment. Once we do that enrichment, we have sufficient information to, or almost all information that we could get from the product selection, to be able to use it in my creative. But that's not it. I cannot start my creative generation yet. First thing to figure out is what are the templates will I use, right? So there could be hundreds of templates in play. There could be a bigger kind of image that I can render, or a smaller format that I can render, which works best, right? So we do something called as rendering rule matching. So for a given product selection, we figure out what are the appropriate templates that I can use, and this is usually a rule matching that we do, where these rules and these templates are kind of curated by our product teams, and we leverage a reverse index on top of these rules, right? So given this selection, we figure out one or more such templates, and each of these template comma product selection kind of manifests into a creative later, right? So once we have the rules as well and the selection, now next phase is the creative generation itself, right? So depending on the rules, right, the rules might say that you would want to use a static asset, right? Then we contact your static asset pool. The rule might say that you would want to render a product image on top of a real life background. Then we use our machine learning models for it, right? So depending on the rules themselves, there are different flows, and then finally the output is a creator. So in this entire architecture, the most complex piece for us was creative generation part, because inherently this involves image generation, and image generations is inherently very kind of computationally expensive, right? And to do this at scale, we had to make some certain choices. So let's slightly dive into deeper as to how did we do that. uh, Here we have what we have done is we have kind of broken down again, right? So using the same ideas of breaking down the creators, we have figured that there are certain elements in the creative, like the textual components that you see here, which are very cheap to render, computationally cheap, right? Because ultimately those are substituting some values onto some variables, right? So those are pretty cheap. There are certain expensive parts, like combining these two fridge images together and subtracting their backgrounds and so on and so forth, all those things that we have seen, and placing that on top of the creative. That is a complex piece in this whole, computationally at least expensive piece in this whole creative. So what we do is we internally represent this as a tree, where the root kind of represents your complete creative, and the children represents your sub elements. So in this case, the textual elements are computationally cheap, which are marked as green. The one in blue, which is the assembly of images, which are essentially as combining one or more images together or doing some image processing there, is essentially computationally expensive. So once we have this classification of child nodes, we can see that, and the structure of the tree is such that it is clear that these siblings are the sibling, children nodes, all the children nodes are independent to each other. So potentially they could be done parallelly as well. So that is the idea that we use. So let's take an example of the flow. So in this example, there are two computationally cheap nodes, the green marked nodes, and there are two computationally expensive nodes which are marked as white, right? So what we do is we kind of mark these computationally expensive node, mark each one of them, and then kind of now the one task unit kind of becomes two task units when we mark these nodes, right? Now now that these are marked and these are independent, we could potentially render them parallelly. So you could imagine that if there are two such complex sub elements to the creative, I do that parallelly. And because these are independent, I could also cache them so that I can reuse in some totally different creative. So we do that as well, we cache them as well. And then once these are processed and rendered and all the child nodes are done, then the root is up for processing. So you can imagine that this whole process kind of needs to be replicated based on the levels of the tree, right? So it basically, one task unit kind of can create more and more task units, right? So to kind of do this in the architectural this thing, what we leverage is we leverage Spark streaming for this. What we do is we kind of we take these product selection cross rendering rule, create a tree, which is the tree that we talked about, the renderable tree, and then we figure out what are the complex, computationally complex nodes in those trees, and we look at the leaf nodes. We mark those nodes and we send them parallelly using a to the next stage using a Kafka cluster, right? We put them in topics, and these are consumed parallelly in your node rendering Spark streaming job. And each of them are processed and then updated in the cache. Once both of these children are done, then the root is up for processing and it's put back into the same Kafka topic. So in this way, doing is we kind of use this looping kind of an architecture to render multi-level tree as well. So it kind of scales to multiple levels and many much more complex images as well. So once the root is done, your entire creative is done, and the output what you get is the entire creative, right? Uh, so at this point, right, like we have kind of explained as to how a creative generation looks like, and how we leverage this kind of an architecture and other techniques to generate very real life looking creatives. So next we'll see how do you kind of where does this system kind of fit in the overall Flipkart context, right? So when you kind of land onto a page, or any category landing page, or a home page, what you see is a bunch of these products discovery experiences, and those are served by different services. We can call them as discovery service. right? And we do that by so what we do in Morpheus is we create these experiences, we index them into these indexes, which are managed by these services themselves. So examples of the services could be recommendation service or a merchandising service, right? Now, when a user lands onto these pages, we figure out their preferences using user profiles and affinities, and then fire appropriate queries on these indexes to get relevant content from these indexes. While these are very relevant to the users, so for example, if you are interested in, let's say, lifestyle category, you will see lifestyle content more, but still not very personalized. We don't really, because there is a limit to the number of content that you can have in the index, right? So the creatives are not extremely personalized and uh, to a user level, right? So to do that, what we are planning to do in the future is to do something called as real-time personalized creative generation. What we do here is when a user lands onto a Flipkart page, we figure out their preferences, and we create a image URL with some information encoded in the image URL as to what kind of creative does the user want, right? Based on their preferences. So if we figure that the user is usually attracted to very bright colors or whatever, we figure out that, and then we kind of code that information in the URL. And once the image kind of starts rendering on your app, that's when the call kind of goes to CDN, and then it talks to Morpheus, and Morpheus kind of decodes this rule, creates a creative. So this is something that we are working on right now, and this can truly scale our platform from millions of content to really billions of content. And this can give our users a very rich personalized experience, right? So before kind of ending this talk, let's look at some of the numbers that we were able to achieve, right? So last BBD we were able to create, last big billion day sale, we were able to create around 1.5 million product selections. We were able to create around 3 million creatives, and till date we were able to assist our advertisers in creating around 1 million creatives. And we generally create around 3 TB of images in a month, and 22 percentage of our view share in our homepage is generated by these content generated by Morpheus, right? So this has been a big win for us in really scaling it up to the next level, and we are very excited about it. And we think that this can really open up a lot of new avenues, right? So that's it from this talk. Thank you for your patient listening, and we'll be happy to take questions.